Lesson 91, Multiplicative Property of Inequality and Spheres. So we have an addition rule and multiplication rule for inequalities. Our addition rule states that the same quantity can be added to both sides of an equation or inequality without changing the solution set to the equation or inequality. The multiplication rule for positive numbers says that every term on both sides of an equation or inequality can be multiplied by the same positive number without changing the solution set to the equation or inequality. So the big difference is when we are multiplying by a negative number. When we do this, the truth statement is going to be altered. The sign is basically just going to flip. So we're going to look at a couple of examples on this. Example number 1, we want to graph this solution. I have negative x is greater than or equal to 2, and my domain are all real numbers. So before I can do this, I need to divide both sides by a negative 1, because I need x just to be x, not a negative x. So if I divide both sides by negative 1, I get x on this side, and then I get negative 2. My sign needs to flip. It is no longer that x is greater than or equal to, because that was the negative. I just need to flip this sign. If negative x is greater than or equal to, then x is going to be less than or equal to. So now I can just graph this inequality. I'm going to start with my 0, 1, negative 1, negative 2, negative 3, negative 4. I'm going to have a closed dot on the 2, and it is going to go off in this direction. Okay, let's do another one. Example number 2. We want to graph this solution. 4 minus x is less than or equal to 6, and my domain are all integers. First, I need to solve for x, so I'm going to subtract 4 from both sides. Then I get negative x is less than or equal to 2. I'm going to divide by negative 1, and then I get that x is greater than or equal to negative 2. So when I graph this, I will start with negative 3, negative 2, negative 1, 0, 1, and I do know it's going to keep going in this direction, but I'm only, because it's integers, going to have a dot on each of these. So the negative 2, negative 1, 2, 0, etc., those are all going to have a dot. Okay, example number 3, last example for this. I'm going to graph negative 3x plus 4 is less than or equal to 13. So I'm going to subtract 4 from both sides. And I get negative 3x is less than or equal to 9. Divide by negative 3, and I get that x is greater than or equal to negative 3. Because remember, I'm flipping that sign. I am going to graph this. So I have negative 4, negative 3, negative 2, negative 1, 0, 1. So I'm going to have a closed dot on the negative 3, and it is going to go into the right. Okay, spheres. So we can find the volume of a sphere as well as the surface area of a sphere. So to find volume of a sphere, here is your here's your formula for finding volume of a sphere. So we have volume is equal to 4/3 pi r cubed, because it's volume. Okay, so using this formula, example number 4 says, find the volume of a sphere whose radius is 3 centimeters. So we are going to take our formula, 4/3 times pi times radius cubed. So what we are going to do, instead of putting this r here, we're going to replace it with what our radius is. And the problem said the radius was 3 centimeters. So we have 3 centimeters cubed. So when we take 4/3 times 3 cubed, and we multiply this out and divide, we get 36. So we will get 36 pi centimeters cubed, which is 36 times 3.14 centimeters cubed, which is 113.04 centimeters cubed. Now we're going to talk about surface area. Surface area of a sphere. If you close your eyes and think about what a sphere looks like, you could cut this in half, and then you would have to cut it in half again, and you would have to cut it in half again, and you would end up with 3 different circles that all would be the exact same. And then if you found the surface area of each of those, which would be pi r squared, then you would have what the complete surface area is for a sphere. So in general, your surface area's formula is 4 times pi r squared. Okay, so let's find the surface area of a sphere whose radius is 4 meters. So we are just taking 4 times pi times radius squared, which is 64 pi meters squared, 64 times 3.14 meters squared, which equals 200.96 meters squared.